Okay, now we're going to move to worksheet number 3. Worksheet number 3, we have a couple of solving algebraically problems. First one is solving algebraically where we have x and the exponent. So what we have to try to do is we have to try to find like bases. So I can't write 16, or I can't write 64 as a base of 16, so we're going to break this down. 16 is really 4 squared, and then that's being raised to the 2x plus 3. 64 is really 4 cubed, and then that's being raised to the x plus 2. Remember the law of exponents: when you have x raised to the a and then to the b, this is where they multiply. Okay, so performing that here, this is 4. The 2 has to distribute through 4x plus 6. Over here, this is 4 to the 3x plus 6. Once you have like bases, the bases basically go away. Set the exponents equal. So when I do that, I'm going to get 4x plus 6 is equal to 3x plus 6. I'm going to subtract my 3x from both sides. I'm going to get x plus 6 is equal to 6. Subtract 6. And I'm going to get x is equal to 0. Next one. We have a radical question. So we got to isolate the radical. The best thing here, because of that negative sign, I'm just going to simply add the square root of 2x minus 5 to both sides. So I get 4 on this side equals the square root of 2x minus 5 is plus 1. I'm going to subtract the 1. 3 is equal to the square root of 2x minus 5. That makes life a little bit easier. We square both sides to get rid of the radical. So we get 2x minus 5 is equal to 9. I'm going to add 5 to both sides. I'm going to get 2x is equal to 14. I'm going to divide by 2. I get x is equal to 7. Anytime you're dealing with a radical equation, you should check it, because sometimes the answers become extraneous and they don't work. Plugging it in, 2 times 7 is 14. 14 minus 5 is 9. The square root of 9 is 3. 4 minus 3 is 1. We're good. Last and final question from worksheet number 3. Complex fraction question. Remember, when you're dealing with a complex fraction, there are 2 parts to it. You got to first simplify the numerator and denominator, and then you do your state change flip. Simplifying the numerator, you get 2d as a common denominator. I multiply the 2 by d, do the same thing to the top. 1 times d is d. I multiplied the d by 2, do the same thing to the 4. I get 8. Common denominator in the bottom, again, is 2d. I multiplied the d by 2, multiply the top by 2. I multiplied nothing, really, this denominator by 1, so keep the 3. So I'm going to wind up with state change flip, d minus 8 over 2d times 2d over 5. The 2d's cancel. I'm left with d minus 8 over 5. Final answer.